machine tool which can be utilized to move any tool mounted on it. It could be a spindle which can be rotating and cutting the material. It could be a grinder. It could be a plasma cutting machine or plasma cutter, or it could be a welding gun. So different type of applications are possible when it is mounted on a CNC machine. So the fundamental still remains same. CNC means, of course, the computer numeric control. We have to provide some line of instructions. Now, how do we generate these line of instructions? There are several ways of doing it. Why I choose this? Because this is quite innovative, I find, and it's open source. It's free for everyone. This particular package called Inkscape, it is not meant for generating the G code, but I am going to use it for generating the G code for you, and I hope it will be useful for your students in future. Lot of research activities can be done here because it's an open source, and if you are interested in your own toolpath planning, you can utilize this package, and you can write your own script in Java in this particular package and embed the code in this through this package to generate the G codes. So as our task is clear, the first task is to generate the G code of a particular image or of a particular path. Let me start with this package. Like I said, again I'm mentioning it is called as Inkscape. You can download it, and if you want, you can do it with me also today during the session. So start downloading it right now. It's called Inkscape. I'm typing in the chat box also. Yes, and also I request, if you like, we can discuss in between also. I have no issues. I hope you can unmute yourself and we can interact. That way it will be like a better session than only I speak and you only listen. So I hope the participants can unmute themselves, right, Dinesh? Okay. I think Dinesh himself cannot mute himself. Anyway, so there are several features listed on the left side of this Inkscape, where you can draw the different entities like circle, rectangle, the cube, and other parameters. There is something called Bezier curve, which we are interested in right now. You might have learned about it in the camp course if you have done. The Bezier curves are the nonlinear curves used to define the boundary of the 2D geometry. So let me draw a random boundary, and we shall try to generate a G code for this boundary. So this is, for example, a boundary which I just created, and I want to generate the G code in such a way that my tool moves along this boundary. Note that right now we are dealing with 2D geometries. Slowly we'll move to the 3D, and then slowly we will move to the multi-axis CNC machines as well. So it is a simple problem, but it is like difficult to solve because you need to have some informations extracted from this particular geometry. Like you require a lot of points on this boundary so that you can generate the G code. But as it's a free-form surface, like you don't know, it's a data given to you, but how to generate G code of it itself is a very fundamental question, but difficult to solve by many of us. So let us see how we can use the Inkscape to do that. So I have created a stoke by utilizing the Bezier curve. Now let me increase its thickness a little bit so that we can see it clearly. So assume that it looks something like that. And now it is placed somewhere on my machine. Assume that the size of your machine is maybe 200 by 200. So you can set the size of the page also accordingly. So let me just change the size of the page. Assume that it is 200 by 200. And this particular image is at the center of it. So I'm going to align this particular at the center of the page. So with respect to the page, I'll align it in the center. Now I want to generate the G code when my coordinate system will be here at this corner. So it can be done. I'll just go to extension, G codes, and there's an option called orient points. If I click on orient points, there are different options available here. The first one is called as 2 points method, in which you can create a coordinate system somewhere on the XY plane, and you can generate the coordinate system with respect to that, or coordinate location where with respect to that your other points will be defined on the 2D stroke which you created. So there are two options here. One is the surface z value. It says that at z equals to 0, where is it? So it is on the surface, it is at the top surface, and I am going to go down by -1 to cut the material. Assume that you want to make the engraving of this, maybe in the wood you have a block of wood and you want to make the engraving in that of this shape. So let me put it -1 here. That means it will make a depth cut of -1 and it will move around and make a slot. Let's say apply for that, and it will create 2 points. I think I received some message. Okay. So let us wait for a while. As you can see here, it has just created 2 points called 0, 0, 0 and 100, 0, -1. So this particular corner is showing the coordinate system. Now this is 0, 0, 0. With respect to this, all other points will be defined. Other than that, there is another point created 100, 0, -1. That shows this distance is 100 mm apart in the XY direction or in the X direction, and in the Y direction it is 0, assuming that this is X axis, and here it is -1. -1 shows that there is a depth you are giving of -1. It is actually under the surface right now. Now let us try to generate the G code. First of all, we need to check whether we are having an appropriate tool which is going to move along this boundary. So for that, again, we'll go to extension, G code, and tool library. Here there are several types of tool. You can use the tangent knife, plasma, cone, lathe cutter, graffiti, or any other just tool. I'm going to surrender a simple cylindrical tool. And simple cylindrical tool is nothing but like a pen. Now you can see that there are several data associated with the tool. The first one is the diameter of the tool. Assume that I am going to have some different diameter, so I'll double click on this until this box gets selected, and I have selected the option to change the diameter of the tool. Assume that it is 5 mm only. Now at what speed you want to move your tool along the trajectory? Assume that it is 500 mm per minute. Penetration angle, it is like vertical or it is going to be enter at an angle, like in the ramp, like the aeroplane lands. Penetration feed, when it is going to penetrate into material, how much should be the feed? Usually we keep it less. And then depth of step, etc. And if there is a tool change, you need to put that number here. Assume that we have only one tool, hence I am not going to change. We'll explore these options later on also. If I change the depth step, means it will reach to -1 in some number of steps. Like if I say 10, that means it will go to this depth -1 with each time reaching to the depth 0.1, 0.1, 0.1 like this. So first it will be at -0.1, then -0.2, then it is -0.3, and in 10 steps it will reach to -1 mm depth. Cylinder has been created. Our path is ready. Our coordinate system is ready. Now let me go to the option. First of all, let me save this tool path at this point of time. I'll just save it in a folder, and I'm calling it as path tool. Okay, so it is saved. Now we want to generate the G code. Again, we'll go to the option extension G code, and what we want is we want to generate path to G code. So this is a path, and we want to convert this path to G code. There are several options. It's usually asked. The first is like, what is the bi-arc interpolation tolerance? The bi-arc interpolation tolerance is the maximum distance between the path and its approximation. So for example, instead of moving on the path like this, it goes like this. Assume that. So what is the maximum distance between the path which it is approximating and the real path? And if there is The distance between these two is more. I mean, the by arc interpolation is not following the or not lesser than 0.05. What it will do, it will divide the path further into multiple paths in such a way that this error may reduce. So like this, now you can see that error has been reduced. Further, if it is not reaching the constraint, then it will reduce it further. So this is how your part will look like to approximate it until this tolerance is achieved. Other options are fine, you can explore. I am more interested right now in going to the preference and giving a path where I can save my tool path. So I'll again go to this folder and I'm going to copy the path of the directory and fine. Remember that if you are preference and say applied, it won't work. This is an issue, I don't know why with the open source, but you have to come to this tab, then click on this path and say apply. And now you have to just wait for few seconds. You can see that the arrow has been generated. It shows that because this is my preference that after generating the code, it shows me the arrows. And once I see the arrows, means the toolpath has been generated. So now let us go to that folder. And here you can see there is the NC file created 0001. I'll right click on this and open it with Notepad++. And you can see it has created a huge code for me just in few clicks. This is good. Then we can test it if you want. So there are several way of testing the path of a written in a G code file. So for that you can use the NC viewer, something called. So you just go to the internet, type NC viewer. However, this is again a open source and free software to show. It sometimes gives some errors, but let us see if it shows it properly. Fine, otherwise I'll show you in another software. So, and if you transfer it to machine, then no issues. Machine will definitely show it nicely. There won't be any issue. So let me copy and paste this G code portion from here to here and plot. Wait a minute. Okay. So this is the path. Now let me play it from the beginning and you can see how your tool will move along the trajectory. Is it visible? You can see the screen or still my PPT is visible?
Yes, sir.
So it has really made my life easy by easily converting the very complicated shape to the toolpath, which now I can directly transfer to the CNC machine. So if you have a CNC machine, just take this file in the pen drive, transfer it to the CNC machine, and it is going to work for sure. Just please hold on. Okay, so let me know if you have any doubt in this Inkscape generating from a simple profile. Before I move to the next problem, let me know if you have any doubt in creating this file, this particular tool, I mean this type of toolpath by using Inkscape. Even if you don't have doubt and you want to explore something else, please let me know. That also we can do together right now. Okay, so I guess there are no questions right now. Let me start with another problem. Again, I'm going to use Inkscape for the same. So this time I will be having a file in which I'm going to fill the inside area also. It was an easy problem, of course, right now, but let me see what if it is required to fill the inside area, because I don't want to only cut the material. Sorry, I don't only want to cut the material from the boundary of the part or of the object which I am creating, but I also want to eliminate the material from interior. I mean, I want to remove the material from inside so that it will be like a pocket. So let us see if we can do that, because now that is even more difficult. So let us create a path from inside which you want to remove the material, and I am using some stroke value over here. Again, the same stuff I'm doing. Now the task is to remove material from inside. Paper size, let us keep this time A4 size. Assume that your bed of the CNC machine is of A4 size. And then I'm going to save this file. So it is saved as now area toolpath. Again, I'll do the same procedure. I'll go to extension, generate G code, and first I'll create two orientation points. Those orientation points will be in a similar way, one at the corner and another at 100 mm distance, and that will be showing us the depth of the cut we are going to make. Then extension will go to and create the tool. So I went to tool library, I have selected a cylindrical tool. Then again, in this cylindrical tool, I am going to change the diameter if required. So let us this time again use 5, and rest of the options I am not going to change. As you have seen that feed rate can be changed and penetration angle and all. So done. Now this is the time to generate the toolpath inside the area. So for that we will go to first extension, G code and area. So here my task is to fill the area which you are seeing right now inside. There is an option called fill area, and you can fill the area by using the zigzag or spiral. Here I am using right now 45-degree angle. That means from the x-axis, the tool path passes will be having 45-degree angle. Let us see what happens if I say apply. So it has just created a zigzag tool path, and you can see that it is at 45-degree like this. Let me just recreate it with another one, or instead of that, we'll do the preview instead of doing the. Sorry, we need to select path and preview instead of say apply, so that we can first see what we are going to develop. Okay, fine. Other than that, if I select the 90-degree option and zigzag, then it is going to fill it in the zigzag manner, but in the 0-degree. That means, sorry, 90-degree means it is having 90-degree from this is 90-degree. So if I say it to be like 30-degree, so from the y-axis it will be having the 30-degree angle. It will take just time. So this is the possibility again. So different values we can keep. Earlier it was showing spiral instead of zigzag. I don't know why, but that toolpath you were seeing earlier was of spiral. If I select a spiral, it will continuously fill it, like starting from here in a single path, it is going away. If you are happy with this toolpath, then you can say apply. What are the different options available here? That's very important. The overlap percentage. The area, because for example, you are using a tool of diameter 10 mm or 5 mm, then what will be the distance between two consecutive passes? It's called a step over or area tool overlap. It is, we are choosing 0.5. Means if there is a tool of diameter 5 mm, then the two passes will be at a distance of 2.5 mm. Correct. Then there's an option called maximum area cutting curves. It is nothing but the, here we have to create the area offset, create several inkscape path offset to the fill area. However, it is, I mean, if we give the larger value than what we are expecting to be filled, it always works. Then we can select the area width. The area width is nothing but the outline start from 1 by 2 of the diameter, that is 2.5, to the area width, whatever we are giving. So tool width is, for example, if it is D, it will take the values in between. If we are fine with this, just say apply. And close the window. Now, what has happened? It has just created additional path for you, like you are seeing here. And I'm going to save this path to G code. Okay. So let me select the whole thing, because I want to select this black color curve also and the inside area also. I'm going to extension G code, and I'm going to convert this path to G code, and the preference of the folder is still same. Say apply. It has been converted. Now you can go to that folder and you can see the number 2 folder has been created. The file which is called as 0002. Open it with Notepad++, and you can see there are several passes. It's a code of 780 lines. Now I'll copy and paste it in the NC viewer. Let me do that. So here is the file. I'm going to drop it here. Let's see if it can show it nicely. There is an issue. I'm not sure why, but this was not I was expecting. So anyway, this always happen with this this NC viewer. So let me open another viewer for this. Just hold on a minute. It is not the issue with the code. Please note that. Don't get confused when you also do. It is the issue with the browser NC viewer, that of free browser viewer. Now, if you open it in the professional one, you will see that it is good. Now let us drop it and check here. So here it is dropped. Now let me back plot the same, and you can see it is perfect. The yellow passes are showing that it is tool is in the air. You can switch off these passes. It's called rapid moves. If I switch it off, you can see that all the rapid moves are gone. These straight lines, what you are seeing, they are the plunge moves. Means in that region, tool is going slowly and trying to enter into the material. If you want, you can eliminate those plunge moves also. But let us have it right now and play the tool. Is it visible?
Yes, sir.
Yes, sir. Yes, sir.
Let me increase the speed. So it has created. So this is how you can fill the inside area as well. Now let me consider another example, and then we'll move to power shape and power mill. This is actually something I like, because if you have a 3D printer, you can use this particular type of things. Assume that you have an image, and let me take my image only. And if how can we generate the G code for an image? So let us consider this particular image. I'm copying it from here and pasting it over there. Not captured, so I'm going to drop it. Yeah. So I have this picture. I want to generate some toolpath which can move on the highlighted area of my image. So for that, there is an option called here trace bitmap. I'll go to the file called I think it is in the path and trace bitmap. It has been opened. Where is it? Control Alt B. This one. And I will generate the. I will use the algorithms corresponding to the edge detection. which you can even use MATLAB or other software also to detect the edges on the image you are seeing. So I use the option edge detection and want to see the live preview. This is how it looks like. If you want to change the threshold, you can change. Assume that we put it 3 and you can see it like this. Although there are a lot of strokes here, so let us consider that. I'm not sure whether my computer can handle this, but let us try to see if we can generate the G code on the image you are seeing right now. So I extracted the edges from the image and going to deposit material. Let me save it somewhere first, because I am like 30% sure whether it will be able to draw that. It may get hang. I am deleting some extra passes. Those doesn't really make any sense. Okay, so this is the image and I want to generate the G code. Even if you have a 3D printer, you can deposit the material along this path. It's good. When you put it in the sunlight, you will see the light passing only through this where the material is not deposited or less deposited, and it will deposit the material where it block the materials, and you will see like the real image in the sun. Nowadays they are doing like this. So I'll go to extension G code. First of all, I'll create the orientation points. Those 2 points will be created, one at the corner, another at another location. Then I'll go to extension G code and I'll create the tool library. It's a cylindrical tool. Say apply. I will change the diameter of the tool. Assume to be it as 5 mm. Everything looks good. I'll just enlarge it a little bit because I just want to see something, and it looks fine to me. Yes, better we save it. I'm clicking here, going to extension, G code, and path to G code. Everything is fine. The preference folder is correct. It is the same folder, and say apply. It will take time. And I'm not sure whether it will create it or not. If not, we will do one thing. We'll reduce the threshold value. We will have less number of strokes and see. But let us try, because you will find that it is like a code of like some 20,000 line or 10,000 line. It is going to generate a huge code which is like almost impossible to generate manually or even by other CAM packages also. That's why I like this Inkscape. At least it can do something unique which other CNC tool parts cannot do. Oh, I think it did. No, it's still doing. Yeah, it will take time. As you can see, if you have any doubt, that's why in the big in the meanwhile, please ask. We can utilize this time.
So you talked about that we can set the path of the tooling, right? Machining path. So
Yes,
is there a way that we can check the amount of time it will take with the
yes, you
given
can.
feed, and then we can decide the shortest amount of time, no?
Yes, you can do that. Not in Inkscape, but in the professional CAM package. I think it's not possible in Inkscape to do that.
Okay, sir.
But I'll show you. I think it's a good question, Kiran. I'll show you in Power Mill how you can calculate. And the shortest path is like the always a good research area, and we are doing a lot on that part. We are trying to deposit the material with the minimum tool lift in a continuous motion without lifting it. Like it starts, and without lifting the pencil, I ask you to fill the entire area, something like that. So it makes sense, but here it is not possible to calculate. Anyone else? Any question?
Hello, sir.
Yes.
Sir, as you talked about the like, it is a two-dimensional thing, right,
Yes.
sir?
Yes. Yes.
Sir, if we if we talk about the 3D printing of that, and if we give a particular height of that, if you have like printed your image, sir, it will be in 2D, sir. Now I just want to be print it into 3D direction. Sir, what would be your concern in that part, sir?
I'll tell you. Don't worry. So right now this is just 2D projection, and you want to deposit multiple layers of the same type, or you want to change it in each layer.
Yes, sir. If we just take an example of a face of a person,
Fine.
we want to, yeah.
Deposit a few layers of the same kind. Nah, I got it.
Yes, sir. Yes,
So
sir.
for that,
After
if
that,
you
it will
remember,
like, sir, like if we are depositing layer by layer, then the deposition will be different. Like if we went from our face to our nose, there will be different layers, sir. Yes, sir. In
no,
that sense, I'm telling, sir.
yeah. So I mean, on the same part, on the same plane, it is going to remain as you are seeing that toolpath we have generated. But as you are seeing, we have to generate like deposit several layers. Okay, that you can change here. Depth is step. Right now, it is reaching to a depth of 1 mm, minus 1 mm down in a single step. Okay, here what you want, I understood. You do one thing. You create right here like mm, here instead of -1, you type for example 10, and each layer is 1 mm. Assume that it is not 1 mm. Then you write 10 here. Then it will create 10 layers. So we'll try that. We'll see, but not with this heavy code. But I'll come back and I'll show you. It is possible. We can do that.
Yes, sir. I got it. Like, sir, we have to like if you are gonna like print a type of a pyramid, it will change. It is like a path, sir, of that.
Yeah. Then it is not possible here. That I'll show you how to do in the Power Mill PowerShell. I'll show
Okay.
you.
Okay.
I
Thank you,
got
sir.
your point because the cross section is changing, right? Each time.
Yes, sir. Yes, sir. Exactly, sir.
It's not possible here. That for that you can use Ultimaker, Cora, and all. But if you want to use and you want to play and you want to do some research, yes, you should be able to get some control. That I'll show you in Power Mill and PowerShape quickly.
Okay. Okay. Thank you, sir.
Yeah. Anyone else have any doubts in what we have seen so far? Okay. So let me just show you what we created. So we created just 003. Let me drop it in the let me close this first and drop this 0003 toolpath, which is of my face, and backplotting it. I don't want to see these yellow paths. Those are the rapid motions. And not only that, I want to see only the top view. Top view. So here you can see, if I play, okay, it is not showing because it's moving very fast and it is not even able to capture the whole thing. So let me try to move slowly, and then I'll show you how this. You can see that tool moving on the tool paths. Is it visible? Okay.
Yes, sir. Yes, sir.
So it is going to deposit the material on these tracks what you are seeing. So if you have, for example, let me go slow. I think then it may show, but this is the backplot issue. Let me show how it is visible in the Inkscape. Sorry, NC viewer. NC viewer. Okay, it has created it. It can help. It will look good. Don't worry. You can see that it is drawing also while moving. And this is a toolpath of 18,000 line, 18667. So just such a huge toolpath it has created for you like in few seconds. Okay, so this is the Inkscape. This is something unique and you might have never seen before. That this, I'll tell you one more thing. This package is not meant to generate G codes. It is meant to create images like schematic diagrams. I also use it for that only, but there are options and now people are utilizing the software to generate even G codes. Okay, so now as many of you are interested in 3D printing, it seems I'll start showing you I'll definitely show the 3D printing stuff also. Let me but start with the machining first. Okay. So this is called power shape and this is power mill. The power shape is a CAD package. Power mill is the oh wait a minute. Both are power shape. Unfortunately, let me switch on the power mill. Power mill. Where is it? Power mill. So power shape is a CAD package. Here you can create CAD, you can modify CAD, and you can do the activities related to CAD. While power mill is a CAM package where you can generate tool path. So the CAD related activities are like playing around with the CAD models, playing around with the curves, playing around with the surfaces, playing around with the nerves and other stuff. I mean, for editing the CAD, these curves, these surfaces, and all. While the CAM package deals with the generating toolpath. So assume that now I'm showing you the fundamental thing, and this is how all 3D printing software also works. But for example, you have retrofitted your CNC machine, which is 5-axis CNC machine, with a welding gun. Now, how can you use that 5-axis CNC machine for depositing the material? Now, this is a big manipulation, and many people fails to do that. And assume that you are trying to make an object. So I am going to give you the demo of how to deposit material and also how to remove the material. So let us start with first removing the material thing. Assume that I want to make this cone. I just created a cone and let me see its shape and size. So its bottom radius and the top radius are given us here. So assume that its bottom radius is the top radius is maybe 25 mm and the bottom radius is assume 100 mm and the entire length of this thing is 100 mm. So this is how it looks like, and we want to create this part. Say okay, this part is created. So fine, I'm going to save this first of all in a folder which we created earlier, and I'll call it as the cone. Here, to create the cone, I'm going to remove the material from a block. So definitely there is a block and I'm going to remove material from that block. Also, let us consider that there is a substrate, first of all, on which we will be removing the material and that substrate will remain. I mean, it will not, we are not going to remove that substrate at all. That part also we'll see. So our aim is to make this part. Let us transfer it to Power Mill. I have selected this part and I'm going to, because this is the only thing I want to do in CAD, I want to create the part and I create it. Now I'll transfer it to Power Mill. And you will see today the benefit of why we have 5-axis. So this is the part here and I want to create it from a block. So let us start with, these are the fundamental steps you should use for creating any geometry in Power Mill or generating toolpath in Power Mill. Those are, first we select the part and create a work plane, and I'm going to create it at the bottom of the part. So here on the bottom of the part there is a work plane. I'm going to activate it. So this work plane has been created. If you want to see, it is here. Then after that I am going to have a block. Block means raw material. Assume that I have went to market and bought a cylindrical block which looks like this, and I'm going to remove material to bring the shape of the part in the shape of cone by using a milling operation. Assume that you have not really got 200 mm diameter cylinder in the market, but instead what you have got is maybe diameter of 220, and its height is also not, you are able to get 100 mm. Instead you have got 150, and I'll tell you why it is important as well. Or assume that minus 20, not much actually. So we have now retrofitted, I mean, fixed this particular block onto our CNC machine from the bottom, the one which is shown here in the transparent color. This one, what you are seeing now. I'm talking about this. So we have just fitted it onto our CNC machine and we are going to remove material. Let us save this project also at this point of time. And I'm going to save it in the same folder. I'm calling it as machine own. Fine. I have created a plane. I have created a block. Now feed and speed. Okay, these options we'll see later. Let us first create the tool. So I am going to assume that I'm going to remove this material by using an end mill. And this end mill is of 10 mm diameter, which is conventionally and easily available. Maybe let us start with 16 mm diameter. That is also available in market. And its cutting length, please note that the cutting length is 50. There is a shank on top of which is not cutting length, but it is just the shank and the plain shank, and its length is assumed to be 60 or maybe 70. We can have a big long tool also. And there is a holder on top of it, which is having a diameter, upper diameter 30 and maybe 25. Its length is not much, it's only 30. The overhang or the entire tool which is outside this part is 100 mm. So 100 mm is outside. So this is the tool I just created. Now by utilizing this tool, I am going to remove the material. So for that, we need to use some tool path. This is the first tool path I am using. And right now let us use, there are several tool paths. In one day, not in one day, in 2-3 days, I cannot cover all the tool paths, but it is to you. You can explore it as per your requirement. You just want to give the introduction to a CAM package. So I'm going to use an option called modal area clearance for the removal of material from a 3D structure. We need to wait for a while. Now this form will open. Here we'll start from the beginning. We have already defined the work plane, which is at the bottom center. We have already defined the block. We have already defined the tool. Now, is there any machine tool? You know, even if you have a CNC machine, maybe 5-axis, 3-axis or whatever, you can make a CAD model of it, or you can ask your vendor to give the CAD model, and that can be imported here. The entire machine. I do not have any right now. Then limit on the tool path that beyond this you don't cut, something like that you can put. Then this is the main strategy. It's called model area clearance. There are options like offset all, offset model, and raster. Okay. So assume that this is the cutting passes. I am going to select the raster. Raster is, you have already seen in the Inkscape. That's why I selected it. It has nothing but the back and forth passes. Then how you are cutting? There are two options for that: profile and area. So in the profile cutting means outer periphery cutting. There are three options: climb, conventional, and any. What is climb? Climb is like when the tool moves, the uncut portion will be always on the left side of it, while the conventional is the uncut portion will be always on the right side of it. It is important because that will allow your chip to flow in one direction, and for the surface roughness of the part also it is important. So right now let us not get bothered about it and use the option any. So we are not bothered whether the uncut material is on the left side or right side. The tolerance, the tool path created, how much it should have the tolerance, the deviation from the real path. It depends on the machine and your accuracy of the machine. So let me use 0.01. It's quite high. And I am going to leave 1 mm material behind that I'll remove in the finishing operation. So right now, our job is to create a roughing cut. I mean, we'll roughly create some near net shape, which we will clean later by using a different cutter very slowly, nicely. Then the next option is step over. Please note, step over is the distance between two consecutive passes in the XY plane. For example, your tool is cutting like this. So if this is the first pass, what will be the distance between the next pass? You know that it is approximately should be 50% to 75% of the tool diameter. Our tool is 16 mm. I am going to use 12 mm as the step over between the distance between two consecutive passes. What will be the step down? Means after one pass, how much down it should go. That is called a step down. It depends on the cutting edge. So we have a 50 mm cutting edge. We can use a quite large value. So let me use at least 20 mm as the step down. Then there are options corresponding to the raster tool path. What will be the angle at which you want to cut? For example, I want to cut at 45-degree angle. And do you want to do profiling? Means in the end, do you want to make a cut at the profile of the final shape of your object? So let us do that in the after or before. So I am interested to do that in the after. Other options we can explore later on. Let us now just move to the important one, which is called as the tool axis. Right now we are looking at the 3-axis milling machine. Assume that you don't have a 5-axis CNC machine. And today you will see the advantage also of the 5-axis CNC machine, that how it can save the time, like somebody has just asked also. Otherwise, if you use the 3-axis CNC machine, it will take a lot of time. So always the tool is going to be vertical in the case of 3-axis CNC machine. So I use the option tool axis always vertical. Rapid moves means always the rapid passes will happen at a height from the block. So you see this height, that is 10 mm. So the tool will always go 10 mm above to make any rapid pass to avoid accidents. There are options corresponding to lead in, how the material is going to enter into the raw material. It is important because this is the flat end mill cutter. You have seen it. It has a flat end. It cannot drill into the material. It cannot plunge into the material. Therefore, usually we say that the tool should go in a proper manner, like ramp into the raw material. So I will use an option called ramp. Now it will go like you see in this diagram, the aeroplane lands, right? It lands like tangentially, right? That is how it will also enter into the material. Other options, let us keep the default right now and calculate the tool path. I think there's a message. Will you please go a little bit slow? Okay, Bashir. I think you are already recording. Otherwise, like I have 15 more minutes. I'm not sure whether I'll be able to show you the uh, area filling thing. Okay, so fine. Let me go slow. Okay, so you have seen that I just created a tool path corresponding to the roughing cut. Now let us try to simulate it. Tool path, I extended this tree over here, simulate from the start. And I'm going to play. It was very fast, I understand. So let me go slow. And let me know if you are able to see this. Are you able to see the motion?
Yes, sir.
So this is moving in the raster
Yes,
passes,
sir.
right? Like we discussed. So these are the raster passes. And I'll show you the other options also, like what happened when we go with the offset all and other passes. Fine. So you can notice that it is going even below. You may not even want to cut the bottom part. Assume that. So you may say there is a limitation on cutting the part. Let us first try to see its volumetric simulation also, so that you can really feel how the material will remove. Give me a second. It always takes some time. Fixed direction. Just some more time. Okay, nice. Now you can right click, simulate from the beginning, and I'll go like a little bit slow, not that fast. and now it will do the profile cut to make it nice in the end. But it is cutting unnecessarily on the bottom also, which may not be required. This pass may not be required. We can make the limitation on the and pass also. That we'll see later. So it is fine. Right now I could see that I have removed some material, but it is having some staircase. I mean, it's not the final finishing, right? So can we finish it further to make it smooth? So yes, for that I'll again go to toolpath and I'm going to create a toolpath, but this time a finishing toolpath. You see this finishing? There are several options for that. You can use the surface finishing, you can use steep and shallow. Surface finishing, if you select the surface, it will finish around that surface only. So let us see if we can use surface finishing in this case. I selected the surface and I selected the strategy called surface finishing. What I want to now, I don't want to leave any thickness behind, and I want to clean the entire area nicely. Also, you will see that part. If I generate the tool path right now, I'm not changing anything. It has created a tool path like this, but just along the boundary. It is showing this is the step over. Means in this case, this step down is nothing but the step over, because it depends on the direction you are moving. And that pattern direction can be changed like this. So this is pattern direction. If you change it to U to V, instead of moving like this, it will move up and down on the heel. I mean like this. You can see that. So different type of patterns will give you different types of RA value. Okay. So you can even change, instead of plunging the direction from the top, you can make sure that the direction of the plunge is coming from the bottom. It goes down like this, then goes up, then goes down, then goes up. Just a minute. I've selected this option. Wait a minute. We need to play around with this. Yeah, now it is fine. Let me just show it to you again. I'm going to activate this, start from the beginning in the view mill and play. And this time we'll go fast. Yeah, any doubts? You can ask by the time it is going on. Now I will run the surface finish tool path on top of it. Right? We have finished up to this. Now I'll do the surface finish. But still, I'm not very happy, right? Because still it has some cusp heights over here, right? It has some, it's called cusp height. You can learn about it more. The definition I'm telling. You need to reduce the step over to make it really smooth in that manner. We can do that. So I'm going to exit from here. That is obvious that this is not a good uh, surface finish which we required in the end, of course. So let me reduce the step over. And it always happens when you do the machining on the slant features. So it is taking time. I have already clicked. Okay, let's not click unnecessarily.
So this is not going quite.
Your voice was breaking actually. Can you repeat?
And so we're getting the exact that we need for the.
No. You are not audible. Can you Just type, or I mean, it was breaking a lot, your voice. Can you try again?
So he's asking in the chat box.
Okay. We are not going to get exact dimension. Of course, you can't. And that's why you need 5 axis. Don't worry. Very good. You will see that's the requirement of 5 axis. Na? Otherwise, why we need 5 axis? You will see that today. Even though you can see that I'm using a lot less step over. I go in any direction. Even if I do like this, I can never really get very exactly like absolutely good RA value. It is fine. Done. Now let me do the next pass. It is fine, but still, there are marks if you just look at carefully or closely into it, and it will take huge time. Now let us make that. Let us have a look into this. Let us try to note down the time it is requiring. So let me go to the first toolpath and go to the statistics of that. So stats of the first toolpath says, with this feed and all these feed and speed which you have setted, it is going to take a total 20 minutes and 54 seconds. So I'm noting it down. 24 minute 54 seconds. You also note it down. 20 minutes 54 seconds. Then let us check the second toolpath. How much time it is taking? The finishing toolpath, so called. So roughing and finishing, the finishing toolpath is taking 1 hour 14 minute 50 seconds. So total time required for this is coming to be 1 hour 34 second 50 1 hour 34 minute 50 seconds. Okay, fine. Let us give it some name. I am calling it as 3-axis roughing operation, and this one is 3-axis finishing operation. Now what if I tilt my tool and then do it? Then it is called as the multi-axis toolpath. Let me see if with that same toolpath it can do. I actually forgot. I believe that it requires end milling, but let's see. And this time I'm not going to keep my tool vertical. It will actually tilt itself, and you will see how much benefit we are going to have. Okay, it did that. Wait a minute. Just a minute. It has selected the wrong surface.
Sir, I think it won't be possible.
It will be, don't worry. Why not?
Sir, if it is tilt,
Sorry. Because that time surface I selected was by mistake got selected this top one. You will see that. Don't worry. Okay. There are issues. I'll tell you what are those issues, but it has been done. Now let me give it as name 5-axis finishing. The only issue is my tool is small. It's not a very big tool. I can't do it like in a
yes, sir.
single go. Okay. That's the only issue, but otherwise it is fine. And we will do that. We have to change the tool. And that's why we are using this CAM package. Na? because it helps us in seeing that, okay, tool is small or tool is big. So let me activate this from the beginning and you will see the issues.
I was I was going to ask this question, sir.
What? What you were asking? That
He was thinking of asking this question. That's what he's saying, sir.
yeah. What was that? I answered. I just want to know.
I guess like you can speak out.
Go ahead. What you are saying? So you see that it is not cutting from this pink portion because that is not meant for cutting, and it is colliding also. Wherever it become red, that is means it is colliding. It's not a right tool. We have to increase the length of the tool. So let us create one more tool and see. I am going to create a tool, and it is going to be another end mill cutting tool because it works, and its cutting length. I'll put like 60, or let us put 100. You will see maybe more, 120. It's a large tool. Assume that. And don't worry, we'll see that. But if we have a smaller tool also, can we do in the steps? So don't worry about that. We'll see that thing as well. No, this is 20, and overhang is going to be 100. That makes sense and looks good also. Something like that. So let us start. We need to just change the tool in this particular strategy. Instead of number 2, I'll use number, no, sorry, instead of number 1, I'll use the number 2. Okay, I have not selected the surface and I'm not able to select the surface. Oh, come on. That is sometimes issue. Done. Now let us see the time we are saving over here. Let me run the first tool path, that is cutting in the 3 axis, again in the view mill, and simulation from the start. Let us start it. Okay, fine. This is our roughing cut. And now if I use the real one, activate also, and you see that just by pressing the, can you see that?
Yes, sir.
Yes, sir.
Okay, it has really make us like, maybe it really works. So this type of finishing you can never get. Of course, there are some issues on the top. We can eliminate that. Again, playing around with the strategy a little bit. Let's see if there are other options I can play around. Okay, let's see. Surface outside is fine. Uh, Radial offset and I want to actually offset it. The bottom is fine. Lower limit is fine. So our finishing, I think here only. So anytime if you want to see what does this mean, you click, put the cursor there and press F1. It will take you to the help and you can see. I want to do it in the steps. Oh, that is radial offset. But I don't want to make the radial offset. Okay, I think that's not possible. We'll explore later. But if you don't want to go like completely down, and assuming that there are issues and it may happen that you will face, I mean, if the tool may not be able to cut that much, you can still leave some material in the back or you can make an offset. Okay, so it is fine. Yeah, I think there is nothing else remaining to explain. If you see the tool axis here, it is automatic, so it will automatically tilt. Anyway, now what I want to show you, if you are happy with these tool paths, assume that what we want to see is whether we are really able to I mean, in real life, how will it happen? So let me consider a robot. Let me bring a robot over here. So I'll go to view interface and I'll want to see the vertical plugin window. And we are very rich here in Autodesk. You can use any robot. I'm going to use a Fanuc robot. It's a big one. It will take time. And here's my robot. Wait a minute. I just forgot to tell you one thing. We have not checked the time, right? Let me see the time of the 5-axis finishing. So I'll go to stats of it. It is taking 1 minute. So the work which we were doing like earlier in 1 hour 34 minutes, here you can do it in 20 minutes, 21 minutes, 20 for roughing and 1 minute for finishing. That's the power of this stuff. Okay, so I want to just show you that, for example, this is your cutting tool mounted over here. You can simulate still different tool paths. So let me just quickly start showing you the simulation. Robotic cell, I am fine with. Yes, I want the tool path work plane 1, which I created earlier. Robot program, if you want, we can save the robot program. Later on, we'll see. This is the main button, the robot control. I'll first bring my robot to the home. Then in the beginning of the position, and then you can start or simulate in the fast speed mode. So, can you see that?
Yes, sir.
How the robot
Yes,
is
sir.
moving, right? Okay, it makes sense and it has just created. Is it going down into the? Okay, it is cutting table. Fine. For that, you need to create another work plane and lift it a little bit. Otherwise, it is going to cut your table itself. But fine for now. Then I want to show you how it will behave if I change my tool. Activated. I have activated another one. I am going to the home in the beginning, and started recording. Can you see that how robot got tilted?
Yes, sir.
Let
Yes,
me
sir.
go slow,
Yes, sir.
right? So this is how it is going to happen. For example, you don't want to give priority to the motion of the robot and instead you want to make the priority to the rotary table. You can say that it is on high priority. Or let me put it on high. This is also on high. And let me do it again. It's going at the home position, going back or the top position and recording. Now could you see, instead of robot, what has moved? The table has moved. Let me go slow. Could you see that? So the motions have been reduced. So now I'll tell you something interesting from the research point of view. You can analyze your simulations, whatever you are performing over there. Okay. So for example, you are happy with some tool path and you want to see how it is going to behave. You first save this simulation. Let me save it as a 5-axis simulations and run my tool path again. So whatever I'll run, it is going to save in a simulation file and it's going to record. Fine, it has recorded. Now if I go to the simulation analysis, where is it? There is an error in saving the .psmi file. Okay. Okay, it is saying that there is a collision detected, so it cannot save. And you know the collision because of the tool is going inside the table. We need to lift it a little bit. Otherwise, it's an issue. So fine, let's see if we can still do that. So this is from the research point of view. You can see how these axes are moving, right? Right now, this R axis, which is corresponding to the rotary table, is moving a lot. Other axes are not moving much, right? But what if I give priority to the other axes? For example, I don't give these priorities and I make them static. So what will happen now? Robot will move. I mean, the arm will move a lot. And then you will see a lot of passes. And let me go back to the simulation. I have to save it first. Just a minute. Done. So here you can see now many axes are moving because of the robot. So the same tool path, but just by changing the priority of the tool axis, I mean the machine axis which is rotating, your joints are going to rotate, and of course you can see cutting the same thing, and energy will be consumed more in this case than in the other case. So this is about how you can optimize your tool path. You can study and work further on your tool path by looking at the joint angle, how it is rotating, how it is by using 5-axis and 3-axis. So fine, I think I should stop here for some question answer if you have.
Guys, if you have any queries with the session, you can go with the questions.
You know, if you want to see something,
Does anyone, if you have any queries, you can go with your queries. Because I can assure you, like, no one could explain you this interesting the tool path generation. He was my guide, and I was working with. I mean, I was working with him, and even now I'm working with him. Any queries, guys?
Sir, I have a question, sir.
Suffix,
Like,
Yeah,
yes, sir.
yeah.
Sir, like
yeah,
you simulated this all things, sir. Sir, for our CNC machine, 5-axis machine, sir, do we generate a G code from this, sir, or we simply put like this type of 3D model into that, sir?
in the machine, no, you have to generate the G code. The machine doesn't understand the CAD model. You have to first make the G codes by sitting in front of this CAM package. Then only you have to supply that, I mean, 5 MB or 10 MB file to that machine. That understand that only. Okay, I have not shown you what machine understands, right?
Yes, sir. Yes,
I have not shown that.
yes, sir. You didn't show that, sir.
Okay, then let me show you. Okay, just forget this robot. Let me remove the robot. Otherwise, it takes a lot of time. It just get hang. Okay. Okay. So, for example, this 3-axis tool path or whatever tool path it is, I'll create an individual NC program for that, and I created. This is the NC program. If you activate it, this is the NC program stored. I'm going to save this tool, generate the machine readable file out of it. So how can we do that? What type of machine do you have? Which machine? CNC machine you have? Who was asking this?
Sir, I was asking,
I,
sir. I think it is Simon, sir. Sir,
Huh?
sir, I don't know actually, sir.
Okay. So you should know the controller of it. What controller is in that? Maybe Fanuc, maybe Siemens, maybe something else. So whatever it is, you need to select. You have to select the convert. You have to convert this CL data, coordinate location data, to the NC file, which is readable by the machine. And different machine have different format to read. The file which is working on my machine, maybe Fanuc controller or Siemens controller, may not work in your case. So for that, there is something called post processing of the files. So for that, you can go click here in this particular CAM package, browse the local file. That is a converter, and it will convert your data which you are seeing on the screen to the data which can be transferred to the machine. Okay, so for that, the folder is this PC, I think C, users, I think public, then document, Autodesk, and then you see what is written here, machining post processing utility. So we are going to post process this data and generate. So for example, we have a Fanuc machine. I selected Fanuc over here and I opened it. Here Fanuc has been selected, accepted. Whatever the tool number, do you want the coolant or not, all these options, but you can check, but remember to check this output work plane, because with respect to the center work plane, you are going to generate the data. Say apply and write. It will write a NC code for you. If everything fine, the toolpath will be created without any issue. Oh, it's broken. Something went wrong, and it is because it is having a multi-axis program. Okay, because again, this is an issue. I cannot generate the single axis program by utilizing the by using the this controller. So if you have 5-axis machine, the dedicated toolpath has a dedicated post processor has to be given to you. Otherwise, we won't be able to. So it is not a multi-axis toolpath. First of all, let me just look at it once again quickly. It must not be having the robot in its consideration still. If it is having, it will not generate the toolpath, because otherwise you have to buy that post processor from the vendor who is supplying the machine to you. Let me just try. I'll just try to convince it that I don't have a robot, and I'll keep my tool axis always vertical. This is vertical. Let me recalculate it. Come on. Okay, let me just change it a little bit. Okay, let me just change it. Calculate. I just want to make sure that it forgets that it is really using a robot. It is assuming that we are still using robot. And let me see if my tool is tilting. It is not tilting at all. It is 3-axis toolpath. Creating NC file. Right click. Settings. Let me select Fanuc. It should work. There is no way it is not working. Okay, let me. Folder is same. If it doesn't work, there must be something. Now it is working, because there may be something in the memory of it, assuming that still I have robot and multi-axis thing. Multi-axis required money. They don't give it free to us. So fine, but 3-axis is free. It is always available. Now we'll go to the machine cone NC program, and I just generated one with error that I'm deleting and the real one. Open it with Notepad++. You can see it just created a entire NC code, and it has a line. It has lines of around 4,000. You want to play it? You can do that. You know that you need to, for that, drop it over there in a simulator. Let me drop it here. Back plot, and this is the toolpath. I don't want to see the rapid moves. This is how it will look like. Okay, it's bad. It actually doesn't show us nicely. Let me see if I can see it in the NC viewer. I hope it will show it properly. Yeah, something is there. I think fine. Let me now show it to you. So I'll move from here very fast. Can you see this?
Yes, sir.
So now this is the file going to transfer to your CNC machine. This one layer, I mean on the top. That will come down, that it will come down, that it will come down. Keep on machining. Something like that. Okay, I hope you got it. Now this file can be transferred. And I think you only ask about that, right? How can you use this same software for 3D printing, right?
Yes,
Where
sir.
the
Yes, sir.
layer data is changing. Na? So what
Yes,
I'll
sir.
do, I'll give you a lecture of mine that is of 2 hours, where I have just explained about how these CAM packages can be used for generating toolpath. You will like it. Sending it in the chat box. There you go.
Thank you very much, sir.
Okay then, Dinesh.
Yes, sir.
If there are no other questions, I'll leave.
Yes, sir. Thank you, sir. Thank you so much for the wonderful session. As always,
Sir, how do G code work on 3D printer? You just transfer the file. It works. You can try. For example, you have a 3D printer. It takes STL file, but it convert that STL file to G code, and then it works. So you can right click on that and open with C++. Oh, sorry, Notepad++, and you will see that G codes are written there. So G code works with 3D printers. Any CNC machine usually works on the G codes. Robot works on the ASCII format. You can still read that, what is written in that. Yeah. Aina, is it clear?
Yes, sir.
Okay.
So can we convert G code back to STL?
You can do digitization of the, I mean, if you have a clouded data, lot of clouded data, point, there are softwares those can convert it to STL file, but going back is a difficult thing.
Okay, sir.
Sir, I have a question, sir.
Mhm.
Sir, you are not using any G code, M code in this program.
In this program,
Yes, sir. Sir,
I mean, you have not seen it. Are you
mhm.
saying that there is no G code, M code?
No, sir.
Okay, look here carefully. G
You are
codes are used
working
once
in
in the
robot.
beginning only. You see that G01, G02, G03, G01, G02, G03, G01, G03,
Sir, it's
G02,
already
G02.
mentioned, sir.
Yeah, it's mentioned.
It's already
So
mentioned. I'm saying,
once it is mentioned like G01, then it is not required to again write G01.
no, sir.
Huh. It's clear?
Sir, once I was in Barambula, we were just. Hello, sir. Am I
हाँ
audible?
बोलो बोलो हाँ
Am
हाँ
I
हाँ
audible?
you are audible.
Sir, we were doing this step by step. We were programs, G codes, M codes.
Okay.
सर उसी के साथ हम स्टार्ट करते थे जी कोड्स एम कोड्स के थ्रू वी वर डूइंग दैट
Okay. So any difficulty you are facing?
नो
मतलब
सर
सबसे
नो सर
हाँ अरे वाह बहुत बढ़िया है करो करो कीप इट अप क्या है तुम्हारे पास 5 एक्सिस है या 3 एक्सिस है
सर 3 एक्सिस फानो
करो फानो कंट्रोलर ना नाइस नाइस नाइस
सर
बढ़िया है करते रहो कुछ डाउट हो तो बताओ कभी अच्छा है ऑल द बेस्ट
थैंक यू सो मच
okay, guys. Any other doubts? You can feel free to ask. The session is getting more and more interesting out of time. If no further queries, we'll wind up the session. Thank you, sir. Thank you so much. As always, it was more of much interesting, and students got more involved with the process. Hope that makes what is the success story of this. Thank you so much for that. Always I need a support for everything. Whatever the process I move on in my life. Thank you so much for being supportive all the time, sir. Thank
thank you Dinesh thanks for the invitation bye bye
you. Okay, thank you, sir. Bye. Correct.